Okay, we're going to go ahead and continue on the third tab of our foldable. I told you it'd be 2 days. This is the Unit 12 foldable and probability. So we're going to talk about the second day with and, or. And we're actually going to focus on the and part. The or part we talked about can be a little bit tricky because stuff can overlap. The and part I think is a little bit easier to do. So we'll do a total of 3 slides. And I think you'll catch on to this a little bit easier than the or part that we did the other day. Okay, if you remember from the other day, we wrote this saying up here, Mandy is poor. We know that the or part, which we just talked about, meant you're gonna add 2 probabilities together and then subtract where they overlap, okay, if they overlap at all. The and part we're gonna talk about today, and it says multiply. So basically you're just gonna multiply 2 probabilities together. So this is more than one event. So 2 things are happening. So you're gonna take the probability of each one separately and you're gonna multiply them together. Okay, so you can write this down, but I think this one's pretty logical. Okay, but I'm just going to find the probability of each event and go ahead and multiply both probabilities together. Okay, since they are more than one event, they call them compound events. So again, I'm just going to find the probability of each thing separately and multiply it together. So here's examples 9 and 10, and again, we'll do one more slide after this. Okay, so I'm rolling a 4 on a dice, and I want to find the probability of rolling a 4 and a 4. So I'm rolling the dice twice. So when I roll the 4 the first time, if we're assuming this dice has 6 sides, okay, I'm going to go ahead and multiply the probability of rolling a 4 one time, which is 1 out of 6, times the probability of rolling a 4 again. Now, just because I get a 4 the first time doesn't affect the second time when I roll it. So the probability of each one that I roll should be 1 out of 6. Okay, so again, since it's more than one event, I'm going to multiply the probability of rolling it once, 1 out of 6, times the probability of rolling it again, so 1 out of 6 again, and I will get 1 out of 36. Okay, and remember, when you multiply fractions, you can do it on your calculator, okay, but it's easy just to multiply the top numbers and bottom numbers separately, okay, and you'll still get the same fraction answer. Okay, number 10 up here, flipping a heads on a coin 3 times in a row. So what's the probability that I'm going to flip a coin once and get heads? It should be 1 out of 2. So if I'm going to do it 3 times in a row, again, I'm just going to take each separate probability and I'm going to multiply it together. So 1/2 times 1/2 times 1/2. That's the chance each time I'm going to get a heads, and if I multiply that together, I end up getting 1 out of 8. Okay, we're going to deal with our last part of our notes for our foldable on and or. And it's going to tell you have a bag that has 5 red marbles, 3 green, and 7 blue marbles. And you're going to find each probability. Here's what's important to understand. Okay, if I draw more than one thing out of the bag, it counts as 2 separate events. Okay, and you're not replacing the marbles after you draw them out once each time. So you'll see what I'm talking about when we get to it. First of all, number 11, we need to find the total number of marbles. So I have 5 red, 3 green, 7 blue. When I add those together, okay, you end up getting 15 marbles. So there should be 15 in the bag. Number 12 up here just wants to know the probability of drawing a red. Since it's a probability question, we know it will be a fraction. And I know I have 15 marbles in the bag. So the probability of drawing a red is there's 5 red marbles out of the 15. So it should be 5 out of 15, which reduces down to 1/3. Okay, for that one. Number 13 is an or question. Okay, things are not overlapping, so this one's pretty logical. Okay, so out of the 15 marbles in the bag, it wants to know the probability of getting a green or a blue. Well, there's 3 green ones and 7 blue ones, so altogether there's 10 marbles that you could get out of the bag that are green or blue. Okay, 10 marbles that are green or blue because there's 3 green and 7 blue. So that would reduce down to 2/3. Okay, number 14 up here deals with what we did today, okay, what we're learning today. Okay, the probability of getting a red and a green. Since you are drawing out 2 marbles, this counts as 2 events. Okay, and we're going to assume that we are not replacing them. Okay, unless they tell you in the problem they replace the marble, okay, you're assuming you're not replacing them. So the probability they're going to draw a red out first. Okay, we know there's 5 reds out of 15 marbles. And I'm going to multiply that by the probability of drawing a green out next. Here's what changes. If I drew a marble out the first time, I no longer have 15 marbles. Okay, let's assume I drew a red out the first time. Now you have only 14 marbles. And now the marbles that are left, out of the 14 marbles that are left, how many of them are green? There should be 3. So those are the 2 probabilities that you're going to multiply together. Okay, the probability of getting a red the first time, you had a 5 out of 15 chance, times the probability of getting green the next time, because it said and there's 3 greens out of the 14 marbles left. So I'll go ahead and multiply those together and reduce the answer. When I multiply the top numbers, I get 15. When I multiply the bottom numbers, I get 210. And your calculator should reduce that to 1 over 14. Okay, but again, since I was drawing 2 marbles out, that's 2 things, 2 events. Okay, so I got to go ahead and compensate by taking 2 separate probabilities and multiplying them together. The last one, probability of not getting a green. Okay, so again, we're assuming all the marbles are in there again. So I have 15 marbles. If there are 3 green marbles, then we know the rest are not green. So how many are not green? Well, if there's 3 green ones, then you also have 5 and 7. Okay, that represent the ones that are not green. 5 red and 7 blue. So altogether, that is 12 marbles that are not green. Wait, 12 marbles that are not green. And if you reduce that down, okay, 12 divided by 15, okay, you end up getting 4/5. Okay, so you should get 4/5 for